So for today's discussion, we will have section 3.8, Solving Inequalities. Okay, so let's start with the following notation. So interval notation, we let A and B be two real numbers such that A is less than B. Okay, then the open interval, which we denote by this symbol, open parenthesis A comma B close parenthesis. This consists of all real numbers for which X is greater than A and less than B. Okay, so X is greater than A and less than B. And then we denote this symbol here, and we call it the closed interval. So we have open square bracket, A comma B, and then close square bracket. So this consists of all real numbers X, for which X is greater than or equal to A, but less than or equal to B. So the difference between the parentheses and the square brackets is the equality. For parentheses, we don't put the equality, meaning that underline looking character below this symbol here. Okay, but for square brackets, we put that one. Okay, it's actually half of the equal sign. Okay, and next, the half open or half close. Okay, these are the intervals. For example, we have this open parenthesis A comma B close square bracket. So this consists of all real numbers X such that X is greater than A, but less than or equal to B. So there is equality on the side of B, but there's no equality on the side of A. And also we have this open square bracket, A comma B, close parenthesis. Okay, this consists of all real numbers X such that X is greater than or equal to A. Okay, we have the equality at A, but X is less than B. So we don't have the equality in B. Okay, and I think in some notations, in some references, instead of using parentheses, they also use square brackets, but they reverse it to denote open. Okay, meaning in some references, you might see this symbol here. So instead of parentheses A comma B, they will use this. Okay, they will use this symbol to denote open. So this is a square bracket, but it's facing outward. Okay, this is also a square bracket, so it's facing outward also. Okay, and with this notation, this guy here, okay, this half open interval here, you will see that it is denoted something like this. So open in A, closed in B, or for this interval here, you have here closed on the side of A, but open on the side of B. Okay, so you will see this in other references. But for us to avoid confusion on the use of those square brackets, okay, let us use open parentheses, or let us use parentheses to tell us that it's an open interval. Okay, and the square brackets, we use it for closed interval. Okay. Now, in the definitions above, A is called the left endpoint. So A here, it's called the left endpoint, and B is called the right endpoint of the interval. Okay, so left endpoint, right endpoint, I think the name is obvious. A is on the left, B is on the right. Okay. Now, I would like to introduce this symbol. Okay, and it's called infinity. This is an abstract object describing something that is larger than any real number. So it's something that is very, 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 very large. It represents a very, 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 very large number. And in here, I want to emphasize the following. If we put plus, okay, if we put plus, this denotes the unboundedness of a set of real number in the positive direction. Okay? And then if we don't put the plus, okay, just like this, we mean this guy. We still mean this plus infinity. And of course, if we put minus, okay, this denotes the negative. Okay, this denotes the negative infinity, or it indicate the unboundedness of the set of real numbers in the negative direction. Okay, intuitively, this positive infinity is some very, very, very large positive numbers, and then this negative infinity is the very, 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 very large negative number. Okay, so these two guys, they are just symbols. Okay, and they are abstract objects. Okay, but I want to emphasize that these two guys here are not real numbers. They are not numbers. Okay, they just represent something that is very, 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 very large. Okay, if you think of a number, that infinity there, okay, this infinity here, I mean, if you think of a number, infinity is greater than what number you are thinking, and it is way, 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 way larger than that. Okay, so this infinity or minus infinity or plus infinity, they are not real numbers. Okay, and with this, I would like to introduce the following intervals. So let A be any real number. Then this guy here, okay, open parenthesis A comma plus infinity, and then you see here close parenthesis, okay, consists of all real numbers such that real numbers x such that x is greater than A. So it's any number that is greater than A. Okay, and if we have this, we close A. Okay, so um, open square bracket A comma plus infinity, and then close parenthesis here. So it's the set of real numbers x such that x is greater than or equal to A. So we just put the equality. Okay, and we also have this. So open parentheses negative A comma so negative infinity comma A, and then close parentheses. So these are the set of real, or this is the set of real numbers such that x is less than A. And finally, we have here open parentheses negative infinity comma A close square brackets. So in here we include A. Okay, so this is the set of real numbers x such that x is less than or equal to A. Okay, and we add the following interval. So open parenthesis negative infinity comma plus infinity close parenthesis. So this consists of all real numbers x. So it's any real number. Okay, and you will notice that in here we don't use close or we don't use square brackets on the side of infinity. Okay, because again, that square brackets means that that number is included. Okay, for example, in here we have a square bracket in here and we say that we include A. We cannot include this plus infinity or minus infinity because it's just an abstract thing. It's just a representation of a very, very, very large number, and we don't know what it is. Okay, if you write something, if you think of a number, okay, then plus infinity is way, 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 way larger than that, whatever number you are thinking. Okay, so these are called the interval notations, okay, including the previous slide. Now, in here, we have the intervals on the first column. We have these intervals. On the second column here, we have the inequalities. Okay? So this is the inequality representation of this. Okay? And so on and so forth. Okay? And then on the third column here, we see the graph. So what we call the graph of this inequality. Okay? So notice we still use the parentheses here. Okay? Parentheses here. And then this arrow here, okay? It's the real line. Okay? It's the set of real numbers. But this open parenthesis and then here the close parenthesis and the blue line that coincides with this arrow, it means that we are only talking about all the real numbers within this blue segment here. And if there's a parenthesis or a square bracket, we say that it's included or not. Parenthesis, not included. Square brackets, included. Okay, so observe or try to um, understand the graph of the inequalities. And this graph, sometimes it's helpful in solving certain problems. And now, in here, you see x greater than or equal to a. Okay, so square bracket a, comma, infinity, open parenthesis. So we have this representation. So we have the square bracket here at A, and then we have the blue ray, okay, the blue ray pointing towards this side, pointing towards to the right. Okay, so that by convention, we say this is your positive side, and we say this is your negative side. Okay, so this means that this ray tells us that this blue segment or this blue line here will continue towards that direction. Okay? And then in here, you have this negative for the interval negative infinity comma a, including a. It means x less than or equal to a. Okay? So graphically, we have the square bracket opening on this direction to the left, and then we have the a here, and then we have this blue ray, okay, pointing towards to the left. So pointing towards to the negative direction. Okay? And for this interval, negative infinity to plus infinity, we have these two-sided lines here. So you have this blue line pointing towards to the right and then pointing towards to the left. So it means we are talking about all the real numbers. Okay? So again, interval notation in here, inequality notations in here, and then graphical representation on the third column. Okay? So in here, set notation, we have the open interval a comma b. Okay? So this is an interval as a set. We can rewrite it as the set of all x in the set of real numbers such that x is greater than a and less than b. Okay? So we have the interval here. We have the inequality notation. And then here we have the set notation. Okay? We have the set notation. Okay? Most of the time for us, I will be asking you to write the inequality notation. Okay? Most of the time. There will be times that I will ask you to write the answer as an interval notation. Okay? But if you were asked to write the answer to be in set notation, then you will have to do something like this. Okay? Questions so far? So let us look at some specific examples here. You have open parentheses 5 comma 26 close parenthesis. So this consists of all real numbers x such that x is greater than 5 but less than 26. Okay? So if we write this graphically, so we have this real line. Okay? So obviously, going to the right, that's your positive side. Going to the left, that will be your negative side. Okay? So that will be our convention. And we use horizontal lines to represent the set of real numbers. And then um, you just write where the numbers are. For example, in here you have 5, 5 and 26. And say this is your 5 here. This is your 5 here. And just say this is your 26. Okay? And then we want this interval. So we have open. Okay, open. And then we also have this open because we have the open interval. And then all the numbers in between will be the one we are looking for. Okay, so this is the interval 5 comma 26, excluding 5 and 26. Okay, next you have closed open square brackets, negative 2 comma 8 close parenthesis. So in interval notation, this is written as x greater than or equal to negative 2 but less than 8. And graphically, we have the following. So this is your real line. And suppose this is your 2 here or negative 2 here and then your 8 in here. And then we said we want to include the negative 2. So we write this as a square bracket here and then parenthesis in here. Okay, parenthesis in there. And then we just shade this part here to mean that we are interested in all the numbers in between negative 2 and positive 8, including, of course, negative 2, but not positive 8. Okay? Next, here you have negative infinity to 1. So this consists of all real numbers x less than or equal to 1. Okay? And then graphically, so this is your real line. And then maybe this is 1. Okay, this is 1 in here. And then we want to include 1. Okay, and then you have this Blu-ray here. And then just put an arrow direction, meaning this guy here will extend towards that direction. So going to negative infinity. Okay? And in here you have 2018 comma plus infinity. So this consists of all real numbers x greater than 2018. Okay? And then just try to write the graphical representation. Okay? Now, let us look at properties of inequalities. Okay? And these properties will help us solve inequalities. Okay? Or finding solutions of inequalities. So let A, B, and C be real numbers. Okay? Then, if you square A, it's always greater than or equal to 0. The square of a number is greater than or equal to 0. You have negative 1. If you square it, it's positive 1. So it's greater than 0. If A is equal to 0, of course, 0 squared, it's still 0. So you have the equality. Okay? But whatever number you have, negative number or positive number, if you square it, you will get greater than 0. For a equals 0, you have the 0. Okay? Next property. Okay? The addition properties of inequalities. So it's similar to the addition properties of equality. What you do on the left, if you do it on the right, okay, you will retain your relation. So if A is less than B, if you add C on A and also add C on B, then it will still be less than. Okay, the side of A will still be less than the side of B. So in here, A plus C less than B plus C. If A is greater than B, A plus C is still greater than B plus C. Okay, so what you do on the left must be done on the right to retain the relationship. Okay, so very similar to the properties of, to the addition property of equality. Okay, for the multiplication, however, we need to be more careful. Okay, so look at this. If A is less than B and C is positive, take note of that. Okay, then if we multiply C to both A and B, the inequality will retain. Okay, so we will have AC less than BC. Okay, or if A is greater than B and C is greater than 0, then AC is still greater than BC. Okay, so what you do on the left must be done on the right. Okay, if this is the case, your multiplier is positive, the inequality will retain. Okay, however, you have A less than B, but this time your multiplier is negative, C less than 0. Okay, then the inequality will be reversed. Okay, so if A less than B and C is less than 0, then AC will be greater than BC. And if A is greater than B, and again C is less than 0, then AC is less than BC. Okay? So in summary, if your multiplier is positive, then the inequality will be retained. If your multiplier is negative, then the inequality will be reversed. Okay? So these guys here are very important, especially in solving inequalities. Okay? Now, another property, the reciprocal properties for inequalities. If A is greater, A is greater than 0 if and only if 1 over A is greater than 0. Okay? And then A less than 0 if and only if 1 over A is less than 0. So whatever the sign of your number, okay, if you get the reciprocal of that number, you will retain the sign. You have a positive number, its reciprocal is still positive. You have a negative number, its reciprocal is still negative. Okay? Now, another important property, okay, if AB is greater than 0, then A and B have the same signs, meaning they must be both positive or they must be both negative. Okay? So if you have two numbers whose product is positive, then the two numbers must be both positive or must be both negative. Okay, so take note of this. And then the other one, if the product is negative, okay, if AB is less than 0, then A and B have different signs. One of them must be positive and the other must be negative. Okay? So if the product is negative, then the two factors must have different signs. Okay? So again, another, this guy here is an important property. Okay? So these properties here, okay, they will be used in order to solve inequalities, which is our main goal for this section. Okay, so solving inequalities. Now, an inequality in one variable. So this is a statement involving two expressions. At least one contains a variable separated by one of the inequality symbols. Less than, greater than, less than or equal, or greater than or equal. Okay? To solve an inequality means to find the set of all possible values of the variable satisfying the inequality. So unlike in the linear equation has only one solution. Quadratic equation, it has a maximum of two solutions. Sorry, a linear equation has a maximum of one solution. Quadratic equation has a maximum of two solutions. Could be one solution, it could be no solution, just like what you've seen before. Okay? But for an inequality, we have possibly infinitely many solutions. Okay? And possibly no solution. Okay? So to solve an inequality, we need to find all possible values satisfying the inequality. Okay? So our first example here is that we want to solve the inequality 3x plus 2 less than or equal to 8. So again, in solving the inequalities, we'll use all the properties that were introduced earlier. Okay? So we start with 3x plus 2 less than or equal to 8. Okay? So in this inequality, you see a linear expression only. Okay? So we have the variable x and the expression that we see here, 3x plus 2. It's just a linear expression. On the other side, we just have a constant. Okay? But in either side of the inequality, if the expression that we see is just linear, then the solution will be easy. Okay? And in order to solve that type of inequality, we just isolate x to one side of the inequality, and then all the other expressions, particularly the constants, will be on the other side of the inequality. Okay? So our very first step here, we add negative 2 on both sides of the inequality. Okay? So I added negative 2 on the left-hand side. I also added negative 2 on the right-hand side. And notice, the inequality is retained. So less than or equal in this side, it's still less than or equal. Okay? So if we simplify this, we will get, we have here 2 minus 2. That becomes 0. So on the left-hand side, we just have 3x. On the right-hand side, we have 8 minus 2. So we get 6. So we just simplified. we don't change the inequality. Okay? So again, we want to isolate x. So for the next step, what we're going to do is to multiply or divide the, the expressions on the left-hand side and on the right-hand side by the coefficient of x. So in this case, we divide by 3, the left-hand side and the right-hand side also. Okay? Or we multiply by the reciprocal of the coefficient of x. So in here, what I did is to multiply by the reciprocal of 3. And the reciprocal, it's just 1/3. Okay? So on the left-hand side, I multiplied 1/3. On the right-hand side, I also multiplied 1/3. And take note, 1/3, it's a positive number. And remember, if you multiply both the left-hand side and the right-hand side of the inequality by a positive number, the inequality symbol will be retained. So you will not change it. So you see, um, here we don't change the inequality. And then we simplify this, and we will obtain x less than or equal to 2. Okay? X less than or equal to 2. So meaning if we replace x here by any number that is less than or equal to 2, the original inequality here will be satisfied. Okay? Graphically, we can have this sketched as, so we have here the real line. Okay? Say this part here, it's going to the right. This part here, it's going to the left. And then we have here 2. So let us put 2 in here. And we want x less than or equal to 2. So which means we use square bracket, okay? And we want less than. So the direction of the square bracket will be going to the left. So in here, we have this square bracket. And then we now sketch the ray, okay, from 2 going to the left. So this graph here represents x less than or equal to 2. Okay? Now, if you look at this step here, it's the addition property of inequality. It's also equivalent to the following step. So in here, you have 3x less than or equal to 8 minus 2. Remember your transposition. So we transpose this to the other side. Of course, when you do your transposition, you put one expression from one side to the other side, you get the negative. So in here, you have plus 2. You put it to the other side, it becomes minus 2. Okay? When you do the transposition, the inequality won't change. Okay? When you move an expression from one side of the inequality or even the equality, but to be more precise for this discussion, when you move one expression from one side of the inequality to the other side, okay, the inequality direction won't change. Okay, so this is the corresponding transposition, okay, step. Okay, so you can do this instead of doing this. But again, this transposition here, it's proven by the addition property of inequality. Meaning this is true because of the addition property of inequality. Okay? Question? For the next example here, we have 6 minus 4x less than negative 2. Okay? So again, you see the expression on either side of the inequality is at most linear. So we do the same method as in the previous example. All we need to do is to isolate the variable x to one side of the inequality and then all other else to the other side of the inequality. So in here, we add negative 6 on both sides of the inequality and the inequality is retained. Okay? And then we simplify. We have negative 4x less than negative 8. So 6 and minus 6, they will cancel each other. Minus 2 minus 6, that's negative 8. Okay? And now, to isolate x completely, we divide both sides of the inequality by the coefficient negative 4, or we multiply both sides of the inequality by the reciprocal of the coefficient. Okay? And notice what will happen. I multiplied both sides of the inequality by negative 1/4. So this is negative 1/4. This is also negative 1/4. Okay? And notice, since I multiplied by a negative number, the inequality is reversed. From less than, it becomes greater than. Okay? So from less than, it becomes greater than. Because, again, I multiplied by a negative number. So be careful on that particular step. And then we just simplify. We will obtain, so of course, negative 4 and multiplied to negative 1/4, it's just 1. So we'll just have x. On the other side, we have negative 8 times negative 1/4, that's positive 2. Okay? So we now have x greater than positive 2. Okay? So there's a question. If we were to divide 4 instead, would it change the sign? If we do that, that's a good question. If we do that, so say we have negative 4x less than negative 8. If you divide it by 4, okay, the inequality won't change because you divide or multiplied it by a positive number. Okay? However, if you simplify this, you will have something like negative x less than negative 2. Correct? So the sign didn't change, but take note, the negative there are retained. The negative on this side and on this side, they are there. They are still there. And when you want to get this part, either you multiply both sides of the equation by negative 1, the negatives will be removed, okay? But the inequality will change. That's one way to do that. Or you can move the x to the other side, and you can move this negative 2 to the other side also, okay? Which means now you will have, if you do that, okay, if you move this to this side and then to this side, remember when you move, when you transpose, the inequality won't change, okay? But when you do that, what will happen? So the x will go to that side. It becomes x here. I mean, the negative x will go to that to the right-hand side. We'll just get positive x. And then the inequality there is retained. And then your negative 2 from this side, you move it to the left side, it becomes 2. So notice, you have 2 less than x. Okay? We have 2 less than x. And just like what I mentioned way back, we always want our variable on the left-hand side. Okay? We always want our variable on the left-hand side. So this guy here, it's the same as that guy above there. Okay? Okay? Now, there's a question here. Can't we divide it by -4? Yes, of course. Remember, multiplication and division, they are similar. They use the same operator, multiplication. Okay? This guy here, it's the same as -4x divided by -4. Remember the definition of division? Okay? Definition of division. You have your A over B. Okay? This is defined as A times 1 over B. So, multiplying by the reciprocal, it's just dividing by the actual number. Okay? But since you are dividing by -4, okay? Say you are coming from here, and then you divide by -4. So you have -4x, you divide by -4. Since you are dividing by -4, the inequality should change. Okay? The inequality should change. Because again, dividing is just multiplying with the reciprocal. Are we clear on that? Now, there are some students who do this. Okay? Say, from this part here, they divide by -4. So let's start from this part here. Okay? They divide by -4 and they don't change the inequality. So they have something like this. -4x divided by -4. They don't change the inequality. Okay? So -8 divided by -4. And then when they simplify this, that's the only time they reverse the inequality. Okay? Okay? Now, mathematically speaking, this is incorrect. Okay? Mathematically speaking, this is incorrect. Although, when they followed up with this, so they are reversing the inequality, I can see immediately that they know what they are doing. Meaning that if they multiply both sides of the inequality by a negative number, the direction of the inequality must change. That I can easily observe. Okay? But again, the change in the inequality occurs at the moment you put a multiplier. Okay? At this particular moment, not on the simplification. This part here, it's just simplification of this. But you did your multiplication at this part, precisely at this part. Okay? So you have to change the inequality at the instant you put your multiplier on both sides of the inequality. Okay? So, they will get the correct answer if they do this. It's totally fine. Okay? But I will give deduction, okay, because of this step. And that's a reminder that the step here is incorrect. Okay? A very minor deduction, a very little deduction. It's just a reminder that something is wrong with the particular step. Okay? So this guy here, this particular steps here, this is a common error of students. Okay? So if you do this, don't worry, you'll still have the majority of the points if everything is correct. You'll get some possibly 0.5 or 0.25 deduction depending on the total points for the particular item because of this particular step. Because mathematically, this is incorrect. Okay? If you are coming from this part. Okay? Other question. So let me just emphasize this guy here. It's incorrect step. Okay? Any question? Next problem here. Now we have a chain of inequality. So negative 3 less than or equal to 2 minus 5x less than 12. Okay? By the way, let's go back to this. Let's just write the graphical representation of this inequality here. So the graphical representation, we have the real line here, and then we have 2. We have 2 here. Just sketch where you want to place your 2. And then you want your x to be greater than 2. So 2 is not included. We use parentheses, and the parenthesis opens to the right because you want your x to be greater than 2. So the parenthesis must open to the right. And then you have your blue ray, okay, pointing to the positive infinity direction or pointing to the right. Okay? Now, let us go to this example here. We have a chain of inequality. We have negative 3 less than or equal to 2 minus 5x less than 12. So notice we have two inequalities here. Okay, we have two inequalities. And at the middle, we have the expression with the variable. Okay? And then on both sides, we have on both ends, left end and then the right end here, we have the constant. Okay? Take note also of the direction of the inequalities. They are on the same direction. So less than or equal here you have less than. Okay? And also observe that the inequality makes sense because as you can see, negative 3 is actually less than 12. Okay? Negative 3 is actually less than 12. Okay? Now, solving for x, as I have said, our expression with the variable x, it's in the middle. Okay? It's in the middle. You want to retain the variable x here in the middle side, in the middle part. Okay? You don't move the variable x to either side of the inequality. You put it always at the middle. So we isolate x here at the middle. Okay? And notice what we're going to do is to add negative 2 at the middle. And therefore, we also add negative 2 on the leftmost and on the rightmost. So you add negative 2 to all parts of this inequality chain here. And notice that the inequality directions here and here, they are not changed because you are adding -2 on all sides or on all parts. Okay? And then we simplify. Okay? So -3 minus 2, that's -5. We have the less than or equal. Here you have 2 minus 2, that's equal to 0. So we are left with -5x here at the middle. And then here we have less than, and then 12 minus 2, that's 10. Now, the coefficient of x here, it's -5. So we multiply again by the reciprocal of the coefficient. If we multiply by -1/5 at the middle, we do that also on this side here and on this side here. But since we are going to multiply by a negative number, look, we change our direction for the inequality. So from less than or equal, it becomes greater than or equal. Here, from less than, it becomes greater than. And we change the direction of the inequality at the instant we put this multiplier -1/5. Okay? And then we just simplify. So we have 1 because we have here -5 times -1/5. Okay? That's just 1. And then here at the middle, we still have x. And then here at this side, you have 10 times -1/5. That's -2. And now we have 1 greater than or equal to x greater than -2. Okay? Now, by convention or in practice, when we have a chain of inequality, we always put the smaller number on the leftmost side. And if you do that, of course, you will reverse again the inequality. So you put this to this side, okay? And therefore, this greater than symbol here, it becomes less than symbol. Of course, x is still in the middle. And then this one here will go to that side, okay, to the right side. That's why we have it here. And notice, from greater than or equal, in here we have less than or equal. Okay? So this is very similar to the previous example when we modified our solution. Okay? From, what was that? From x or from 2, I think it's greater than x, but whatever. When we try to put the variable on the left side, okay, and then the constant on the right side, we reversed our inequality. Okay, so your 2 is greater than x, or your x is less than 2. Okay, so very much similar to what happened in this part here. Okay, question. Now, the chain of inequalities, as I have mentioned earlier, the direction of the inequality must be the same. Okay? You will not see something like this. X greater than or equal to 1. Okay? Greater than, also greater than or equal to 2. Okay? This guy here as an inequality does not make sense. Okay? Or maybe you have something like x less than or equal to less than or x greater than in here, x greater than 1. Okay? Oh, it's the same. What I want to write here is x less than or equal to 1 and also less than or equal to 2. Okay? So you will not see a chain of inequalities, a continuous inequalities, okay, with different directions. Okay, you either have this less than or equal, less than, or this guy here, greater than or equal or greater than. Of course, the equality, it can be in that or not in there. Okay, so you can have something like both less than or both greater than, and you can also have something like both less than or equal, or both greater than or equal. So the equality symbol attached to the inequality, it could be there or it could be removed. Okay, so this guy here, you will not see that. And if you do that, if you do this guy here, then something is wrong. Okay, now graphically, so we have this inequality here. We have this inequality here. Let's have the real line. Of course, -2, it's less than -1 or +1 in here. So -2 must be on the left of your +1. Okay? Or if you have this guy here, of course, 1 is greater than -2, definitely. So you will know if your inequality chain is correct or not. Okay? Now, you have -2 less than. So you have strictly less than. We use parentheses. And then in here, 1 on this side, we have less than or equal. So we include +1. Okay? And then we want all those numbers in between. So we have this graphical representation of that inequality. Okay? Question? Next. Here you have x squared minus 1 greater than quantity x minus 3, x plus 4. So for this example, you see on either side of the inequality, you see quadratic expressions. If you have quadratic expressions, try to simplify, okay? And possibly the inequality will be reduced to linear inequalities. Just like in this example. So first, we multiply this x minus 3, x plus 4, and we will obtain this expression here, x squared plus x minus 12. On the left-hand side, you still have x squared minus 1, and you have the greater than symbol. And it's retained because in here, you just multiplied this expression. Okay? You just expanded this product here. Okay? And then notice, on the left-hand side, you have x squared. On the right-hand side, you also have x squared. So they can be canceled. Okay? So let's try to isolate now this x here. Because as I have said, x squared will be canceled. And to isolate, we add negative x squared plus 12 on both sides of the inequality. So negative x squared plus 12. Here you have negative x squared plus 12. Of course, this x squared will cancel the negative x squared here. This x squared will cancel the negative x squared here. And then we have here negative 1 plus 12. Okay? And in here, negative 12 will cancel the positive 12. So if we simplify, we will have on the left-hand side, 11. And on the right-hand side, we just have x. So 11 greater than x. Or We write this as x less than 11. Okay? And graphically, so we have this real line here, and we need 11. So let's say 11 is in here. Okay? And we need x less than 11. We do not include 11, so we use open. But we want our x to be less than, so the parenthesis will open to the left. Okay? So this is your parenthesis, and it's opening to the left. Okay? And then we now sketch the ray, okay, whose direction is going to the left. Okay? Question? Okay, so let's now go to this example. So in here, we have a chain of inequalities. So you have 0 less than 3x minus 9 raised to negative 1 less than 1/3. Now, this part here, the left sides, okay, the middle and the left side, it only tells us that 3x minus 9 raised to negative 1 is a positive number. This part here is important because we will need to get the reciprocal of 3x minus 9 raised to negative 1. Okay? So in here, this guy here, 3x minus 9 raised to negative 1 can be written as 1 over 3x minus 9. So we need the reciprocal, 3x minus 9. Okay? And we are sure that 1 over 3x minus 9, it's a positive number, which means we can multiply both sides of the inequality here, okay? Actually, in all parts of the inequality, and we are sure that the inequality direction will not change. Because again, we are sure 1 over 3x minus 9 is positive, and therefore 3x minus 9 is also positive. So I am using this property here, a greater than 0, if and only if 1 over a greater than 0. Okay? So that's what we're going to do. We multiply all sides by 3x minus 9. Okay? We also multiply by 3. These 3 here, you can disregard this. Okay? But I am including the 3 because I want to cancel these 3 here. But notice, I did not multiply anything on this side. It's because whatever you multiply to 0, it's just 0. So you are not seeing that 3 times 3x minus 9 in here. And again, 3x minus 9 is a positive number multiplied to 3, which is also a positive number. The inequality here is not changed. Okay? Then we simplify. So notice, if we simplify, the 3 and the 3 here will cancel, and we will be left with 3x minus 9. In this part, 3x minus 9 and 3x minus 9 here will cancel, and we will be left with 3. Now, how come we have this? Let me go back to the previous slide. If we simplify this, this 3x minus 9 will cancel the 3x minus 9 here. So on this side, we'll just have 3. Of course, 3 is greater than 0. Doesn't matter. We already know that. Correct? In here, 3 and 3 will cancel. So we'll just have 3x minus 9. And the inequality there, it's still less than for this. So 3 less than 3x minus 9. Okay? So we'll just be looking at this because anyway, we are sure that 3 is positive and therefore 3x minus 9 is just positive. So this part now here won't matter to us. It mattered in this particular step. We are multiplying by positive number. Okay? But starting on this step, it doesn't matter to us now because anyway, 3 is greater than 0. And therefore, 3x minus 9 is greater than 0. And then from here, okay, from here, we just reversed. We put this guy here on the middle side, okay, on the middle side. Or we put this part here. So we'll just look at this. We now start disregarding this part. So we put the one with the variable on the left side. Okay, that's why we have this 3x minus 9 greater than 3. So there's a question where did 3 come from? In this part, you see you have 1 over 3. I just want to cancel that 3. I just want to cancel that 3 here. So I have to multiply by 3 also. Okay? And then from here, 3x minus 9 greater than 3. We simplify, we solve for x. So we put the 9 on the other side. So if you put it on the other side, let's write the missing step here. We put the 9 on the other side. So we will have 3x greater than 3 plus 9. From minus, you put it on the other side, it becomes plus. And therefore, you will have 3x greater than 12. And then we simplify again. We divide everything by 3. And if we divide everything by 3, since 3 is a positive number, the inequality won't change. So the missing step in here is we divide by 3 both sides of the inequality. Okay, the inequality won't change. Okay, and therefore you have x greater than 4. Okay, now graphically, this is what we'll get. So here you have the real line, and then you have here, say, 4, and you want your x to be greater than 4. Strictly greater, so we use parentheses. X greater than 4, parenthesis opens to the right. Okay, so x greater than 4, parenthesis will open to the right. And we now sketch the ray towards. So again, we want our x to be greater than 4, strictly greater than, so we use open parentheses and it opens to the right. And then we sketch the ray. Direction is going to the right. Okay? Now, let us look at this step. As I have said, you could have multiplied everything by 3x minus 9 only. Okay? So from this step, we just multiply everything by 3x minus 9. So 0 less than 1 over 3x minus 9. And then less than 3 times, we now have 3x minus 9. Sorry, it's 1/3. This guy here, it's 1/3. Okay? And then we multiply all sides by 3x minus 9. So in here, we multiply 3x minus 9. And again, in here, we multiply 3x minus 9, but this is 0 anyway. So it's just 0. And then if we simplify this, okay? So again, from this part going to that direction, if we simplify this, we'll just have 0 less than 1 because this will cancel this. Okay? And then less than, for this part, you have 3x minus 9 divided by 3. But notice, this guy here, 3x minus 9, you can factor out 3. So what you'll have is 1 less than 3 times x minus 3. And then all over 3. Correct? And then you can cancel out the 3. Okay? This and this. You will be left with 1 less than x minus 3. And then if you solve for x, you put your negative 3 to this side, it becomes plus 3. You will have 1 plus 3 less than x, or 4 less than x, and which is precisely this x greater than 4. So you can do this step here, or you can do this step. It doesn't matter. You will end up with the same solution. Okay? Question? Next, we have here x squared less than 1. Now, listen very carefully. So for this, if you simplify this, you will still end up with quadratic expression. Now, how do you solve this? If you are left with quadratic expression, however you simplify it, what you're going to do is to put everything, okay, to put everything on one side of the inequality, and the other side of the inequality must be equal to 0. Okay? So, from here, x squared less than 1, we put the 1 together with the x squared. And you will end up with x squared minus 1 less than 0. And then from here, if you can factor the quadratic expression, factor it. For example, this x squared minus 1, we can factor this into x minus 1, x plus 1. And of course, the inequality is retained because anyway, we just factored x squared minus 1. Now, remember this property. AB less than 0. So if AB less than 0, then, okay, then A and B have different signs. Okay? So we can think of x minus 1 as our A and x plus 1 as our B. And we have A times B less than 0. So we have A and B must have different signs. And there are two possible cases. Okay? So we divide this into two cases. The first case is that x minus 1 greater than 0 and take note of this word and. X plus 1 less than 0. So they have different signs. But these two inequalities here must be satisfied at the same time. That's why we have and. So this is the first case. The second case, I'll use or here at the middle. The second case is what if x minus 1 is the one that is negative and x plus 1 is the one that is positive. So that's the other case. X minus 1 less than 0 and x plus 1 greater than 0. So this case here, they are still having different signs. Okay? This case here, they have different signs. This case here, they have different signs. So the possible solutions to this inequality could be this, or both of them. Okay? Let's work on this part. First, x minus 1 greater than 0, it means x greater than 1. And then we have here n. Take note of the word n. You always write that. And in here, x plus 1 less than 0, it means x less than negative 1. But look at this. You want something that is greater than 1 and also less than negative 1. Is that possible? Graphically, it's something like this. So this is your negative 1. This is your positive 1. This x greater than 1 is represented by this. So you have all x's greater than 1. This x less than negative 1, it's represented by this. All x's less than negative 1. But look, you want n. You want n, meaning must be satisfied by both inequalities here. If I get my x somewhere here, okay, it is satisfied by this inequality, but not this inequality. Okay? If I get my x somewhere here, then this x is satisfied by this inequality, x greater than 1, but not this inequality here. Okay? So this case here does not give us any solution. So no possible solution. Okay? Understand? So again, you want these two inequalities here be satisfied at the same time. Okay? But there is no possible x satisfying both inequalities here at the same time. So no possible solution for this case or from this case. From this case, we have x minus 1 less than 0. It means x less than 1. And we have x plus 1 greater than 0 or x greater than negative 1. So same, let us try to sketch. This is your negative 1. This is your positive 1. You want x less than you want your x less than 1. So this is your inequality, or this is the sketch of that inequality. But you want your x to be greater than negative 1. So this is now the sketch for that inequality. Now look at this. If I get my x in here, I don't get the x somewhere here. Correct? If I get my x somewhere here, I don't get any x somewhere here. On the other hand, if I get my x somewhere here, I have that x somewhere here. Which means if we combine them, the solution that we want, okay, graphically is this. Everything between negative 1 and positive 1. So this is the graphical representation of the solution. We combine, okay, if we combine, this guy here is represented by x less than 1 but greater than negative 1. So this is the set of solutions. Okay? So for this example, we want to solve the inequality x squared greater than 1. So this is very similar to the previous example, except that this time we have greater than inequality here. So just like before, what we're going to do is to put this 1 from the right-hand side to the left-hand side and then compare the expression with 0. So doing that, we now have, or we now rewrite this inequality as x squared minus 1 greater than 0. And then for the left-hand side, we factor it into x minus 1 times x plus 1. And since we just factored x squared minus 1, the inequality remains the same. So this is still greater than, equal to, or greater than 0. And then we treat this as our A, this our B, so that we now have a product A times B that is greater than 0. So this means both A and B are positive or both A and B are negative so that we can have this inequality. So the complete solution, we will divide this into two parts. Okay, the first part, let's say both A and B are positive. So we have x minus 1 greater than 0. And so take note, we want these two inequalities satisfied. So and x plus 1 greater than 0. So from here, we have x greater than 1. And then we have the end. Okay. From here, we have x greater than negative 1. Okay. So we want all x's that satisfy these two inequalities. So if we try to graph Okay, if we try to graph these two inequalities here, this means the following. So we have saved this is your -1, this is your +1. For this inequality, we want our x to be greater than 1. Okay, so this is open parenthesis and this goes to the right uh, direction. And then here we want our x to be greater than -1. So we still have this parenthesis, and then the direction is still going to the right. Now we want end. So we want all those x's satisfy these two inequalities. So if I get my x somewhere here, although it is satisfied on this inequality, x greater than -1, it is not satisfied on the other inequality here, x greater than 1. Okay? So you would see that the one we require so that these two inequalities are satisfied is this inequality in here. Okay? That is, if I get the x from here, I will have my x there. So it's in this part. Okay? So this this guy here gives us some possible solutions for x. But let us consider the other possibility. The other possibility is that both a and b are negative. So we have x minus 1 less than 0 and x plus 1 less than 0. So if we calculate, we will have x less than 1 and x less than -1. And then similar to the previous uh, uh, illustration here or the previous solution here, let us look at the graph. Okay, let us look at the graph. Still, let's put our -1 here, +1 here. And then for this inequality, we want x to be less than 1. So this is your 1, open parenthesis, because we are strictly less than. And then the direction is going to the left. These are all the possible x's. And then for the other guy here, we have less than -1. So we have this parenthesis and then still going to the left. And then same analysis as in before. If we get our x somewhere here, there's no x for the other inequality. But if we get our x from somewhere here, there's a counterpart to the other inequality here. Okay? So if we combine these two these inequalities here with the word and means that these are possible solutions. Okay? So the word or here tells us that the set of solutions for this inequality is this set and also this set. Okay? So this set plus this set. Therefore, our final answer would be the following. So our x greater than 1 or or x less than -1. So this is the inequality solution or the inequality uh, notation for the solution of this inequality x squared greater than 1. Okay? So meaning you choose your x to be greater than 1, this inequality here is still is satisfied. or you choose your x to be less than -1, this inequality here is still satisfied. Okay? So take note, you cannot combine this into a chain of inequality, unlike the previous one. Why? Because if you want to combine them, okay, some students do this. You will have your x in the middle. This is your -1, and then this is your +1. So you want your x to be greater than 1. So you have this. And then you want your x to be less than -1. But this guy here means that your -1 should be greater than x. So what is that? Okay, your -1 should be greater than negative your x, meaning you have something like this, correct? But notice, what is this? This means -1 is greater than +1. So this guy here doesn't make sense, correct? This guy here does not make sense. Your -1 is greater than +1. So some students do this, and this is not correct. Okay, even if you trick that and write that as 1 less than x less than -1, this is still it's not correct, because this still tells us that -1 is greater than +1, which is not correct. So you cannot combine this into a chain of inequality. Unlike in here, okay, we have combined them into a chain of inequality, okay, or a sequence of inequality. So you have your x greater than -1 but less than +1. Okay? Okay. So for our last example here, we have x squared minus 3x less than -2. So just like before, we put everything on one side of the inequality and compare it with 0. So we put -2 from the right hand side going to the left hand side. So we will have x squared minus 3x plus 2, and we want this to be less than 0. And then this guy here, this is factorable. Factor it into x minus 1, x minus 2. Okay? So x minus 2. And again, this is still less than 0 because we just factored this. So just like before, let's treat this as A, let's treat this as B. And the product AB is less than 0. This means that A and B must have different signs. So two possible scenarios. So say x minus 1 is less than 0, and x minus 2 is greater than 0. So this is negative, this is positive. If you multiply them, you'll still get negative. So if we calculate this, we have x less than 1, and we have here x greater than 2. So graphically, let's put 1 in here, 2 in here. For this inequality here, x less than so x less than 1 here. We have this parenthesis here. It's an open parenthesis, and it's opening to the left because we want our x to be less than. Okay, so you have this. And then for this guy here, you have your x greater than 2. So it opens to the other direction. But notice, they will not have common values for x. You get your x somewhere here, it's not in here. Or you get your x somewhere here, it's not in here. So for this case, there is no possible solution. Okay, so no possible solution. Okay, so for the other case, okay, we have, or here, for the other case, we'll have x minus 1 greater than 0 and x minus 2 less than 0. So this is positive, this is negative. If you multiply them, you'll get negative, right? But this means your x must be greater than 1. And here, your x must be less than 2. So graphically, we have 1 here, we have 2 here. X greater than 1, it means you have this, and the direction is going to the right. Here you have x less than 2. We have here, and the direction is going to the left. Okay? So if I get my x somewhere here, it's not here. Or if I get my x somewhere here, it's not here. But if I get somewhere between 1 and 2, say this one, we'll get that there. Which means graphically, the set of x, okay, that we need is all those real numbers between 1 and 2. So, combining, okay, combining these two inequality here, what we need is, or are the values of x for which x is greater than 1 but less than 2. So this is the solution to this inequality. Okay? So that's my last example. And I suggest you work on as many problems as you can on page 80 of the 016 module. So thank you for staying and have a good day.